Okay, let's begin. So before we begin today, just a couple of quick notes. First off, I do want to remind you that we are, and I want to make sure I'm saying this correctly. Yeah. So I do want to remind you that we are, next week is spring break. So I won't be assigning anything during that time. Also, let's see. Once we come back, I'm going to have set up Google Classroom. So we're going to be using, again, we'll still be using Discord, and we'll be using Google Classroom kind of to communicate back and forth. Mostly Discord and email to communicate back and forth, but that's where I'm going to be posting things like videos and assignments and stuff like that. Okay, so that's what we're going to be using. Let's see. I thought there was something else I want to tell you guys, but I do not remember, and I did not write it down, so we'll go with there wasn't. So, that being said, today we are supposed to work on multiple choice. So if you have any questions regarding the multiple choice, please ask. I know there were some yesterday, and let me see if I don't remember which ones they were, so I'm going to have, I can't remember who asked them, but if you could maybe repost those questions that you had from yesterday that we didn't do, that would be fantastic starting spot. 15, 16, 17. Okay, let's start there. That should have me. Okay, so from here, let's see what we have. The number of bacteria in a culture is given by this function right here, where t is measured in days. On what day does the average rate of change of n of t take a maximum? Okay, so let's see what we can do here. So first off, I think you guys would agree, this right here represents a position function. So this is a position function. And they are asking us, so this spits out positions. Let me just make sure. The number of bacteria in the culture, yep, is given by that. On what day does the average rate of change of n of t take a maximum value? So this is an interesting one. Let's see what we can do with it. I don't think I've ever done this one. Well, let's see what we can do. I'm just going to play with this a little bit and see what happens here. So we want to know on what day does oh, I'm sorry. No, I read this wrong. Where am I getting the word average? That's weird. Okay. So I don't know. I don't know where that word average was coming from. I was seeing the word average and it was really messing me up. So, okay, on what day does the rate of change of n of t take a maximum value? Okay, that makes a lot more sense. So, first thing we want to do is they're asking where does the rate of change of n of t take a maximum? So, of course, the first thing I want to do is find what is the rate of change. So I'm going to find the rate of change by taking the derivative of n of t. So n prime of t equals this. So this one we should be able to just do by hand, even though it's in the calculator section. And I'm going to clean this up a little bit just because I think it might be easier to deal with. Okay, so we have our rate of change function. Now what they're asking is, where does this function take a maximum value? Well, I want to find a maximum for this function. So imagine if I had given you a function, I have this function, and I say find the maximum. what would you do? Well, you'd take the derivative of it, make a sign chart, and find out, where there's a maximum. So guess what I'm going to do? I'm going to take the derivative again. And that's going to give us, let's see, actually, I'll do quotient rule. I was going to see if I can get away from quotient rule, but I'll do it anyway. So derivative of t is 1 times the bottom, which is t squared. Don't forget, you could do this on a calculator. I'm just being a little lazy by not doing this on a calculator. So minus, let's see what we have. So minus the derivative of the denominator, which is 2t, times the numerator, which is t, all over the denominator squared. So t squared plus 36, quantity squared. Let's double check that before I move on, just to make sure I took that derivative right. My brain is not quite functioning as well as it should be right now. So the derivative of the numerator is 1, derivative times the denominator, which is t squared plus 36. So first part is correct. Minus the derivative of the denominator, which is 2t, times the numerator, which is t. Perfect. Okay, that looks good. So now what I want to know is where does, and again, I'll clean this function up, but where does this function right here have a minimum or maximum? So cleaning this up, I get this. So t squared plus 36 minus, looks like 2t squared, right? 2t squared all over this, which gives us, looks like 36 minus t squared, right? Yep, 36 minus t squared over t squared plus 36 squared. That's a terrible parenthesis. Okay, so the next thing that we're going to do, right, is since we want to find this where this has a maximum, I'm going to set it equal to 0 and solve. So I'm going to set this equal to 0 and solve. So first off, and I'll answer, I know there's a couple questions in there. There's a couple questions in the Discord, but I'll finish this up and then I'll answer those questions. So at this point, we want to find the critical values. I think you'd agree. The denominator can never equal 0. So this thing only equals 0 when 36 minus t squared equals 0, which is going to happen when t equals plus or minus 6. Okay, so from there, I'm then going to make a sign chart where I have -6 and +6. And I'm going to go and remember, when I plug in values, so when I plug in my number, so I'll plug in like -5 or whatever I plug in, they're going to go into this. Let's see if I can do that really quickly. I might need a calculator, but let's see if I can do it without a calculator. So the denominator is always, so the only thing that matters is the numerator. So if I have like -7, that's gonna be negative. So it looks like it's gonna go negative, positive, negative, which means I'm going to have a minimum here and a maximum there. Okay? And did they ask for what the maximum value was? On what day? Nope. So it'd be on day 6. Okay, so let me go through and answer the questions that were posted in Discord. So first was, how do you do the derivative of the calculator? You cannot. I was kind of, if you have an 84, like you said, you can't do the derivative. You have to do it by hand. If you have an 89 or an n-spire, you can take the derivative. You can do the derivative. But like I said, for the most part, this one you had to just kind of, if you don't have an n-spire and 89, you have to kind of do what I did. There was no shortcut. Okay, so again, the 84, the ones that are not CAS, so the ones that are not 89 n-spire, they don't do symbolic manipulation, they do numerical. So if you were asked to, for example, take take this thing right here and find its derivative at 5, it can do that. Right? It could evaluate the derivative at 5, but it can't actually go and find the derivative symbolically for you. Okay? Before we leave whatever number this was, number 15, did you have any questions? Okay, let's move on to number 16. number 16. I'm going to grab this out. I don't know if I'm going to need the space. I feel like this is one of those ones where I just kind of have to think about it. But just in case, I'm going to play it safe and give myself some space here. Okay. What do we got? The function f is continuous and differentiable. That's important. On the interval from 3 to 7. The table consists of the selected values of f. Which of the following statements must be true? Okay. So first off, they said, let's think, this function is continuous and differentiable. And they said the minimum value of f on 3 to 7 is 12. That's false. It's not that it can't be 12. It's that we don't know it could be 12. I think you'd agree what could happen is maybe at 5.5, right? Maybe it drops down to 0. How do we know? We don't. These are just some selected values. So that might be true, but we have no way of actually knowing that. So no. Next, there exists a number on 3 to 7. So I'm going to highlight those points from here to here, such that f prime of c equals 0. That is true. And the reason is true is the function is continuous and differentiable. F of 3 equals f of 7. Therefore, by Rolle's theorem, there must exist a c on that interval such that f prime of c equals 0. So this is absolutely true. Okay? Next, on the interval from 5 to 7, let me erase these things. On the interval from 5 to 7, f prime is greater than 0. So that is false. The average slope is greater than 0. But again, as I said before, we could have somewhere in here, maybe at like 5.5, right? This thing could suddenly drop down for some bizarre reason, and then we would have some issue. Now, if they said, if they wanted to use a mean value theorem and say that somewhere it had to be positive, that would be true. But in this case, is it greater than 0 for the whole time? I don't know. There may be some issues somewhere where it's not. So the only thing we can say is that number 2, we know number 2. Okay. In regards to number 16 and the reasoning on there, are there any questions that you have? Okay, let's look at, before I skip it, looks like I skipped number 5, so let's look at number 5. Oh, I think this is a fun one. I think. I will be honest with you guys, I have not done the calculator section very much. I don't tend to enjoy the calculator sections, but I think this one's a fun one. I kind of remember it, I think. Maybe. We'll see. Okay, what do we got here? So, if y equals that stuff and u equals that stuff, find dy dx, where x equals 1 over e. Okay, so let's see what we have here. We're supposed to find dy dx. And we are given the y equals this. Whoops. And that u equals this. Okay, so let's think about what's going on here. The first thing I'm going to do is I've got a couple choices of what I could do. Here. One thing that I could do, and I don't see why it wouldn't work. I don't know if I want to do that, but I could if I wanted to. Excuse me. And it should work, is I could, anytime I have a U, I could plug in this thing. It'd probably make things more complicated, but I don't see why I couldn't do that if I wanted to. So what I'm going to do instead, though, is I'm just going to start with this function right here. This looks the easiest to me. I'm going to start here, and I'm going to go and take the derivative. Now remember, in the end, I'm going to have to I have to take the derivative with respect to x. Okay, so I'm going to have to kind of keep that in mind. So let's see what we got here. Let's take the derivative. So, since I'm doing it with respect to x, I get dy. Well, let's do this. I think this will be a little bit easier. I'm going to say y prime equals the derivative of u, which is u prime, plus 2e to the u times u prime. Okay? Would you guys hopefully agree? That's my derivative. I've done it implicitly. I have some more things to fill out, but that's kind of where I am at this point. Are there any questions on that? Okay, next, I'm going to need to know a couple things. Well, let's see. What are the things I need to know in order to solve for y prime? I need to know what is u prime and what is u. Well, u is given. That is done. This is u, but I do need to know what is u prime. So u prime is going to be 1 over x. And again, there's a question in the Discord, but I'll answer in just a minute. So let's go through and replace all the things that we know. So let's see, y prime, which is dy dx if we want to, equals u prime, which is 1 over x. And then this becomes 2e to the u. U is 1 plus ln of x times u prime, which is 1 over x. From there, what did they want us to do? Actually, they want us to x equals 1 over e. X is a constant. Why are they doing that? Let's see. Give me 1 second. Let me see this. So we did that. Are they asking us to then, when x equals, man, my reading skills today are just terrible. What is going on? I cannot read to save my life today. So the last thing I'm going to do is I'm going to take this value and substitute it into in for x. Wow, my reading skills are just off the wall terrible today. Okay. So let me finish it up, and then I'll answer the questions that are in chat. So we get y prime equals 1 over x, which just becomes e, plus 2e, 1 plus ln of 1 over x times 1 over x. Now, there are some simplifications that we can do here, so let's do that. And I might have wanted to do the simplifications earlier. I don't know if it really matters, but let's see. We get y prime equals e plus, since this is an exponent, since that's an exponent, we can get 2, and I'm going to say e to the 1 times e to the ln of 1 over x. And again, hopefully you notice why I'm doing that, because this piece right here is just going to become 1 over x. So let's do that. Y prime equals e plus 2 e times 1 over x times 1 over x. Getting close here. Y prime equals e plus, let's see, 2e over x squared. Okay, let's see. Oh, the x's. I keep on forgetting to plug in the e's for the x's. I see that. I don't know why I didn't put the e's in for x's. I might clean that up again. If the math is right, I should just be able to plug it in. Let's hope the math is right. Let's hope I didn't make a mistake. So what was E? E was 1 over E. I know this was not the best way of doing this, but I was doing a really bad job of paying attention. But as long as my math was right up to that point, this should still be fine. And now I'm a little bit doubting my math here. So what do we get? We get, that's going to be 1 over E, so that's 2E cubed, it looks like. Was that one of our values? If not, I'll have to kind of redo it a little bit. Looks like I'm going to have to redo a little bit. I probably got lost. But before I do, because this is the main idea, let's take care of some of the questions, and I'll redo a few things I did now that I kind of messed a couple things up on there. First off, let's see. Why do you solve implicitly? The reason we solve implicitly here, and again, I'm going to kind of backtrack a little bit because I did mess that one up here. We solve implicitly because this thing, we're taking the derivative with respect to x, right? But we have variables in terms of y. Our variables are y and u. So in order to do this with respect to x, right, we have to go through and do this implicitly. The only way you would not be able to do it implicitly is if it was with respect to one of the variables given, like y or u. Okay, second question was, that's just clarification. How could you make it ln 1 over x? How could I make it ln of 1 over x? Good question, I think. Let me go through and redo this one now that I've gotten a chance to kind of do it once and kind of get it clearer in my mind. Let me go through and do it again because I did make some mistakes just because I was not paying attention. So let's do a little bit better here. Let's clean it up. Okay. So we have our function, and we said we need to take the derivative of it with respect to y. So I get y prime equals u prime plus 2e to the u times u prime. Okay? Did that implicitly. Next, we wanted to do maybe some substitution. So we were told we need to know what is u, which we know, and we need to know what is u prime, which is 1 over x. Next, let's go plug in the values that we have. So y prime equals u prime, which is 1 over x, plus 2, and I'm going to do it this way. E to the u is e to the 1 plus ln of x, and then that's going to be multiplied by 1 over x. Let's double check the substitution before I continue. I'm not going to worry about substituting into e until I've cleaned this up a lot. I think that's going to help. So let's make sure. 2 times e to the u, which is wait, what? Oh, yeah. U is 1 plus ln of x. Now that makes sense. I was confusing myself here. 1 plus L of x. Okay, that looks good. That looks good. So let's do a little cleanup here. We get y prime equals 1 over x plus 2. This, again, as we said before, I'm going to clean this up into e to the 1. E to the ln of x is just x. So times x times 1 over x. Yeah, this cleans up a lot better. I must have made a mistake before. So we get y prime equals 1 over x plus 2. I think you guys would agree this stuff is going to cancel out. So this is going to be 2e. Now I can substitute in my value. My value for x was 1 over e. So this becomes e plus 2e or 3e. Okay? I know that was a little bit confusing. Hopefully the second time I went through it made a little more sense because it definitely cleared it up in my mind there a bit. Before we continue, are there any follow-ups on that one? I know it was definitely a little rough one just because you're having to do, there's kind of a couple substitutions there. Okay, let's look at number 17. Number 17. What do we got? Okay, I think this one, I don't think I need to copy over. So let's see what we can do here. So the graph of f prime, the derivative of the function f is shown. So remember, this is the graph of f prime, okay? Is shown at the right. The graph of f prime has a horizontal tangent at x equals 0. So right here, and I'm going to do this in bright red, there is a horizontal tangent, okay? Which of the following statements are true about the function? So let's see what we got. So which of the following is true about the function? So f is increasing on the interval from -2 to 1. -2 to, what is it, -1. And that is true. And the reason being is the, what's it called? The derivative is positive at that point, right? Because this represents the derivative function and the derivative is above this, the graph lies above the x-axis. The derivative has to be positive, so it is increasing on that interval. This is true. Okay? So that is true. Second, x has an inflection point at x equals 0. Okay, well, if it has an inflection point, then what should be happening is the function should be changing from increasing to decreasing at that point. But actually, the slopes of the tangent line should be increasing to decreasing at that point. So let's see. I think you guys would agree that if we were looking at our slopes of our tangent lines, these are all negative, then they are all positive. So the slopes of the tangent lines did change. So right here does have to be an inflection point. And then finally, from -1 to 0, it is concave up. -1 to 0, it is concave up. Wait, it is concave up, yeah. Concave up from -1 to 0. But notice the slopes of our tangent lines are negative, which means that they will be concave down at that time. So only 1 and 2 can be correct. Okay, so in regards to number 17, do you have any follow-ups? How can you tell concavity by just looking at the first derivative? Okay, so think about what the derivative tells us. So let's just for a second ignore this problem. Let's just look at a different problem. Let's say this is a position function. Okay, so I'm going to just give you a position function right now. So this is the function f, and it represents a position. If I asked you to tell me about the derivative of f, right? If I said, give me where f prime is positive and where f prime is negative, I think you'd agree what you would do is you'd look at the slopes of the tangent lines and you'd say, okay, as I go along here, all my slopes of my tangent lines are positive. But as I go from here, my slopes of my tangent lines are negative. When you're looking at the slopes of those tangent lines, what are you doing? You're looking at the derivative function, right? Now, if I told you, hey, this function right here is f prime, then those slopes of the tangent lines would be telling you about the second derivative. Okay, so the way we can do it, the way we can talk about concavity is because concavity is all about the second derivative, right? If something is concave up, then it is positive for the second derivative. If something is concave down, it's negative. So in other words, the slopes of the tangent lines to the derivative function are positive or negative. And that's how we can do that. Okay? In regards to that one, are there any questions? I know there's some previous questions and I'll get to them, but let's just kind of finish this one up. So the best way to think about this, so let me restate the question. I understand that the first derivative, but the second derivative I don't get. Like, how do slopes of tangent lines translate to concavity? So the way it translates is, remember what the second derivative does. The second derivative, all it does is take the derivative twice, right? So if I have a position function and I take slopes of tangent lines for the position function, that tells me, it gives me the first derivative. What information does the first derivative give me? Well, the first derivative gives me where the function is increasing and decreasing, right? That's its job. Now, when I take the second derivative, right, as you know, that gives me concavity. So, but think about, again, when we're doing concavity, what are we looking at? We are looking at the slopes of the tangent lines to the derivative function. Okay? So because all we're doing is we're just taking derivatives, but each of those derivatives, as we go further and further down from that position function, have different meaning. Correct. So the question is, so negative slopes of the tangent line to the derivative equals concave down. Correct. So if you're looking at the derivative function and you look at the slope of the tangent line, you're at that point you're talking about the second derivative. Correct. Another question is coming in, I think. Maybe not. Okay, so it looks like there was a follow-up on the one before. Let me double check it. I feel like my math was right on that one. I could have made a mistake. So what I will do for that one, because I don't want to keep on spending a lot of time on that one and make it confusing, I will go through it on my own off stream. And then if there is a problem with it, I will just post a quick YouTube follow-up in the links to give you guys that one. I could have gotten lost in the problem. It was a complicated problem, easy enough to, make a careless error. So maybe I did. But I don't want to keep on going over and over it and just making confusion. So I'd rather go through it one time clean. So I'll do that off stream. Okay. What do we else have here? We did number 17. Have I hit the problems that you've asked so far? Are there any other questions in regards to the multiple choice that you have? Can we do number 8? Maybe. I think I did this one. This one was done on, if you look at... I'll do it again because I can't remember quite which stream. I know I've done this one, and but I don't remember which stream I did it on. And it's pretty quick at this point. I did come back to it, but like I said, I can go through it pretty quickly. So let's kind of go through it. I did get. I think we were right, but I think it was maybe on Monday. But I don't mind. It's like I said, it's a pretty quick one at this point. So I'll just go through it quickly. So let's see what we got here. So we are given this information, and I want to go and find the value of a. So first thing I'm going to do is I'm going to take the derivative of both sides, because if both things are equal, both their derivatives are equal. So I get 15x squared equals f of x. And remember, I get f of x because that is the second fundamental theorem of calculus. Next, now I know, make sure you understand, at this point, this equals this stuff, right? I took the derivative, that has to be true. So now what I'm going to do is I'm going to replace this stuff right here with this. So I get 5x cubed plus 40 equals this. From there, sorry, that's an A. From there, I'm going to integrate the right-hand side. So I get 5x cubed plus 40. Sorry, that was 15. I see it. I made a mistake. Let me replace that correctly. So one more time. I'm going to replace 15x squared with what I have there. So now I integrate, and I get 5x cubed from a to x, which leaves me with 5x cubed plus 40 equals 5x cubed minus 5a cubed. 5x cubes cancel out on each side. I get 40 equals negative 5a cubed. Negative 8 equals a cubed. A equals negative 2. Okay, so that is number 8. Follow-ups on that? Okay, the question was, for number 12, you told us to plug it into our calculator, but I can't get a right answer. Let's see what happens. Let me grab my calculator. So let's see. The functions f and g are defined on the closed interval from there, and g of x equals there. When will they have the same average value? Okay, so what do we want to know here? We want to know, when are they going to have the same average value? So in order to do that, what we'll do, I'm going to find the average value of f. So the average value, I'm going to look at the average value of f from here to here. And I'm going to be setting that equal to, the average value for g. So from there, let's see what we got here. Let me just double check my setup before I go on. Looks good. So from here, I get 1 over b times the integral of f of x, which is cosine 2x dx, and that's going to equal 1 over b from 0 to b of g of x, which is e to the x minus 1 dx. Let's go and do some antiderivatives here. So I'm going to do cosine of 2x. Let's start with cosine of 2x. So I'm going to let u equal 2x, which means du equals 2 dx, which means 1/2 du equals dx. So doing that, we get 1 over, looks like 2b. I'm not going to worry about my limits of integration right now. I'm going to keep those blank. And that's going to be of cosine u du. And that's going to be equal to 1 over b of this stuff. And this one I'm not going to have to do any u substitution. Let's just double check that before I move on. That looks solid, I think. So from here, we get 1 over 2b. The integral of cosine is sine, so times sine of u. But I'm going to do my resubstitution here. So sine of u equals 2x. And that will be we will be integrating from 0 to b. And that's going to be equal to 1 over b times the integral of that other function, which we get e to the x minus x from 0 to b. So from there, boy, this one's really going on here. What do we get? We get 1 over 2b times the sine of 2b minus the sine of 0, which is just 0, so I'm going to ignore it, equals 1 over b times e to the b minus b minus e to the 0, which is 1. So we get this. Okay? From here, let's keep on going. If I multiply both sides by b, these b's are going to cancel out here. So I get sine of 2b equals e to the b minus 1. So let's set one side equal to 0. This is going on and on and on. So sine 2b minus e to the b plus 1. That's going to be my new function, and that's the one I'm going to plug into my calculator. And what are we looking for? I have completely forgotten. We are finding the b's. We're finding the zeros of that function. So let's go and plug that into our calculator, making sure, of course, that our calculators are in radians, which I think I know how to do. I do. The question is, did I drop a 2? And the answer is I did. Thank you. I did drop a 2. That would have caused all sorts of problems. I dropped a 1/2, not a 2, but I did drop it. You are correct. Okay. Let's see here. Let's plug that into our calculators. Haven't used my calculator in a while. So what do we get? We get 0.5 times, I'm going to say the sine of x minus e to the x. I don't even know where that button is on my calculator. I literally don't know where that button is. Oh, there it is. E to the x plus x plus 1. Let's graph that. Let's see what we get. So I get, and I'm going to have to use, looks like I have 1 at 0, but I'm also going to have to find my other, I'm going to have to find my other 0. So let's see if we can do that. So first off, before I do, it says it gives me the option to change both my graph angle and my geometry angle to radians. Do I change both? I don't know what it means by the fact that your calculator gives you the I would assume yes. When they say geometry angle, I can't say that I know what they're actually talking about there. But I'm going to go with yes. So let's see here. Let me solve. That is something I have never seen. So I got, of course I got the wrong number. I must have made a mistake somewhere. Because I got 0.7129, which is not one of our options. So I have a couple of these to go off the stream. I'm probably just going a little bit too quick here. Okay, so I will do those. Those two are a little more complicated that we talked about. I'll do them off stream and put them back up so that we can make sure we're getting the right answers. But if you're not getting the right answers, once you have the correct function, you just have to play around with it. Unfortunately, the calculators are the calculators. Okay? So I obviously made a mistake somewhere. I'll see if I can find it really quickly, just while I'm flying through here. So that is correct. Second line, 1 over b, 0 to b. Substitution is correct. That looks good. Our u substitution was correct. That looks good. 1 over 2b, sine of 2x. That is correct. Correct? Yes, because that becomes sine of u. That looks good. Then I get 1 over 2b sine 2b minus sine of 0. That's fine. This becomes e to the b minus e to the 0, which is 1 minus 0. That is correct. Which becomes, I multiply both sides by b. That's fine. So that becomes 1/2 sine of 2b equals, that looks right. Sine, move that over, minus b plus. I am not seeing the error right offhand. Let's see, someone else see it? Did you put sine of x or sine of 2x into your calculator? Good question. How did you know that? I plugged it into my calculator wrong. Yeah. No, I put the wrong thing to my calculator. It's C. I don't even know how you did that, how you knew that, but I absolutely did put the wrong thing to my calculator. So let's fix that. How do I fix that? I said it out loud. Okay, well, kudos for, give me a second here. I'm trying to remember how to go back to my thing here. So, exit maybe? You are absolutely right. So let's put that at sine of, that was some really good listening on your part, because, yeah, let's see what happens when I draw that. That looks there. Let's go to the intercept, which is this, that, and I get 0.854, which looks like it is C. So yes, it was me being bad on the calculator. You're absolutely right. So everything else is right. My calculator stuff was wrong, which makes sense. I hate using a calculator. Okay. So good. I didn't have to redo that one. That one was done correctly. I just can't plug things in a calculator correctly. Okay, let's see. Couple questions coming in. Maybe a question coming in on this one. And while it is, I'm going to grab some coffee, because apparently, oh yeah, I've only drank like a cup of coffee. No wonder. I need to be on like at least 4. Okay. The question was, the graph intersects the axis at 0, 0, so why don't you use that number? The reason is they're asking for the average value, so from 0 to 2b, from 0 to b. So I'm not going to use 0 because 0 is one of the endpoints. I want to use the stuff on the inside. Okay. Again, I don't want to use an endpoint there. Okay, let's see. I thought I saw another question. I think there was a question about number 8, but not number 8. I think we did number 8. Am I missing something? Let's see. I thought I saw something I was missing. If you posted a question number that I missed, could you please ask it again? Because I feel like I thought I saw something in chat, but maybe it was something we had already asked. Because number 8, I know we did do. So let's go from there. Do you have any other questions regarding the multiple choice that I can brutally butcher and make it more confusing for you guys? Hey, it's the day before vacation. If I don't leave you a little bit confused, then I haven't done my job. Okay, let's look at number 11. Wait. Oh, okay. I'm like, didn't we just do this one? But we did one very, very close to this. This is actually very similar to the one that I did before. Are we going to do free response 12? Let me double check. Did I say we were going to do free response 12? Let me look at my announcements. I thought Friday, let's see, Friday. Oh, and go over problem 12 and finish out the questions you have in multiple choice part B. Okay, let's see what we got here. So you're right. I do have problem free response number 12. You are correct. Let's do this. I am starting to... This one's going on a little long here. Let's see where I'm going back to here. Nope. 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 Okay. Let's see. I want to hold off. So let me do this. I'm going to hold off on number 11. I'm going to give you guys a shot. And here's the reason I want to give you guys a shot. Is very similar to the one that I said I'll put up on YouTube. The idea is almost exactly the same. So I'd like you to play with it because it is a good one for you guys to play with instead of me going over it. And especially once I put out that question that I said I put up on YouTube. So try that with it first. If there are follow-up questions, we'll just kind of hit them at some point. Maybe I'll throw up a video for it during the week. That way you guys get a chance to kind of do it on your own. Other than that, let's move on to the free response question number 12. Because I don't want to lose anything here. So let's do that. Actually, if you guys don't mind, I want to do something real quick here. I am going to, and I'm going to come back. I'm going to shut the live stream off really quickly and then restart it so that I do number 12 completely blank, so that when I throw it up on YouTube, I don't really usually throw up the multiple choice stuff on YouTube as much, but I'd like to break this video up into two. So again, I'm going to stop my live stream right now, and then I'm going to restart it so that I have so that I can post this up into two different pieces. So I will be right back.